Today's the first lesson for graphing linear relations, and I want you guys to understand the difference between a relation and how the graph could be represented using different variables like x and y. So a relation is a description of how two quantities are connected. So two quantities that change together, we call them variables. And one quantity that will depend on the other is called a dependent variable. So it's dependent on another one. And the other is called a independent variable, and it's a variable whose values you choose. So it's pretty much independent of any other variables. Okay, so it has its own numbers. Okay, for example, so a relation can be represented using one or more of the following. So you could represent a relation using words in a sentence. You could use a picture. You could also use a table of values. And also you can represent using an equation, which we will be looking at. And after that, you could represent a relation using a graph. Now in graphing, we call this a ordered pair, xy. Or another word for ordered pair, we call it a coordinate. And it describes a point on the graph. So again, y is the dependent variable. On the other hand, x is an independent variable. Now that we understand what are the variables in terms of using that to graph, so let's take a look at the data. The data can be either discrete or continuous. So you will notice that the discrete data cannot be broken down into smaller parts. So you will usually draw the graph in a dotted line. On the other hand, if you have a continuous graph, that means that the data can be broken down into smaller parts, and you could draw it in a solid straight line. Okay, so let's take a look at example 1. A plumber charges a flat fee of $50 plus $35 per hour for a service call. Now, what is an independent variable here? Independent variable is always per something. So in this case, it's $35 per hour, which is time. So independent variable is time in hour. And the dependent variable is another unit, which is money, the cost, or the charge in $sign. So to formulate an equation, you have to do the let statement. Let T be the number of hours, and let C be the total charge in $sign. So therefore, my total charge is going to be $50 plus $35 per hour, which is T. So that is my equation. So I could rearrange this if I want to look a little bit more in like a slope y-intercept form. The slope y-intercept form looks like this. It looks like y is equal to mx plus b. And we will look into that later. So if I have to rearrange this, it could be c is equal to 35t plus 50. So the one with the variable comes first, and then the constant number comes at the last. So let's complete a table of values for up to 8 hours. So independent variable is always the first one, which is time. And the dependent variable is the second column, cost. So for time, let's start with 0 And if we're doing up to 8 hours, I'm going to do an increment of 2 hours. So 2, 4, 6, and 8. So if I were to do 0 hours, what that means is I'm going to plug in 0 into t. So it's 50 plus 35 times 0, which is 50. Now if it's 2 hours, I'm going to plug in 50 plus 35 times 2. So 2 times 35 plus 50 is going to give me 120. Same thing, 50 plus 35. So now I have 4 hours. So you multiply the 2 and then add 50, you get 190. And then you'll do same thing, 260 and 330. So if I have to translate this table into a coordinate or ordered pair, it will be 0, 50, 2, 120, 4, 190, and so forth. Okay, because the coordinate is always x, y, in this case t, c. Now we want to graph the relation for up to 8 hours. So when we are graphing it, you always start with the title. So you can start by saying the y value, the total charge, versus number of hours, and that will be your title, y versus x, and make sure you always underline the title. And then let's label my x and y intercept. For x intercept, it's going to be time in hours in bracket. So this is 0, and I could do 2 square bracket representing 1. So this is 2, 3. Now when you are labeling it, your units, your increment has to be very consistent. Okay, so if I went by 2 spaces for 1 hour, then that has to be consistent. And then my y-axis, it's the total cost in $. And for this one, if I take a look at the the numbers for cost, I start with $50 and I go all the way up to $330. So what I'm going to do is I'm going to, let's say, I will do 5 spaces for 100. So 1, 2, 3, 4, 5. So this is $100. And then another 5 space for 200. 300 and 400, and that's it. The reason why I did 5 spaces is because I want to make sure that I have enough space so that the graph takes up the whole grid. If I were to do 100 for 1 space, then your graph is going to be only up to here, this area, which is very tiny. Okay, so you want to space it out so that your graph takes up the whole, most of the grid, if possible. So I'm going to label the points now, the coordinates. So let's say the first point is 0, 50. So 0, and it's right in the middle. Okay, so it's at 2.5 points. And when it's at 2, it's going to be over here, because each square is going to represent 20, right? So 20, and then for 5 spacing, it gives you 100. And then at 3, it's 190, so it's right in the middle, in between here. 4 at, sorry. Oh yeah, so 4 is at 190, my apologies. 4 is at 190, 6 is at 260, and then 8 is at 330. So right in the middle here. Okay, great. So what you're going to do is you are going to use a ruler. Make sure you use a ruler, and it must be a straight line touching the points. So unfortunately, I don't have a straight line here, but please use a straight line. And then don't forget the arrow at the end, and it is a solid line, okay? The reason why it's a solid line is because you can do half an hour time or 45-minute time, so it can be broken down for the time. So that's why it's solid, okay? But all the points should be on the line. Okay. Now, so identify this relation as linear or nonlinear. So as you can see, it's a solid straight line. So the equation of the y, if you take a look at it, it's increasing by the same number. What do you notice? So if I were to subtract 120 minus 50, I get 70. And every time I subtract it from the second value of the first value, you get a $70. Okay, so it's consistent. So therefore, yes, it's linear because the graph is a straight line. And another way to look at it is when you look at the equation, the degree, right, of the t is 1. So if you see like square here, that means it's not a linear relation. So that's another way to look at it. And the degree of the equation is 1. Okay? Okay. Now, let's take a look at example 2. So not all relations are linear. Okay, so let's see. Look at the relationship between the side length and the volume of a cube, where side length is measured in centimeter and the volume is measured in centimeter cube. So what is the independent variable? Well, we do know that when you draw a cube, right, the volume of the cube is defined by side, side, side. So S cube, right? Length times width times height. But because it's a cube, they're all the same. So independent variable will be the side length. And then dependent variable is the volume, because volume is dependent on the length. So what is the equation? Well, we could say let S be the side length in centimeter, and let V be the volume in centimeter cube. So V is equal to S length times width times height, which is S cube. Now it says complete a table of values for this relation. So independent variable comes first and the volume dependent variable last. So we could start off by saying, okay, let's do 0, 1, 2, 3. If my side length is 0, obviously 0 cube is 0. If it's 1, 1 cube is 1. 2 cube is 8. And 3 cube is 27. Don't forget, it's 2 times 2 times 2. So if I have to rewrite this in a order form, it will look like this. Now that we have the table of values, let's graph this. So again, for the title, you could say volume versus the side length. And you must underline the title. And for independent variable for x-axis is the side length in centimeter. And for dependent variable is volume in centimeter cube. So for side length, I'm going from 0 to 3. So I'm going to do 0 here. And then for every 5 spaces or every 4 spaces, I could do 1, 2, 3, and 4. Okay. And then for volume, I'm going from 0 to 27. So I could do maybe every 2 spaces for 10. So, or actually, I could do every 4 spaces for 10, 20, 30. Okay. Now let's graph this. So 0, 0 here at the origin, 1, 1, so it's like really tiny here. At 2 is 8, and 3 is at 27. So as you can see, you will notice that the graph is not a straight line. If you use a ruler, it doesn't connect all the points. So it will be looking something like this. I will be connecting the points like this. It looks like that. So again, V is equal to S cubed. So when you take a look at the graph, is this linear or nonlinear? It's definitely nonlinear. So why is it nonlinear? Well, it's because the graph is not a straight line. For sure. You can't use a ruler to connect the points. Another thing is that if you look at the equation, what's the degree? It's 3. It's not 1. So when you look at the equation of the degree is not 1. Okay, so when you have an exponent that is 2 or 3, it won't be a linear equation. Okay. Now let's take a look at the properties of linear and nonlinear. Okay. Now direct variation, this is a very important term, is a linear relation where one variable is multiple of the other. And the equation will always look like y is equal to mx. And another key information is that 0, 0 is pretty much the point that will be part of this graph. So it starts at 0, 0 at the origin. On the other hand, when you have a partial variation, it's a multiple of the other plus a constant amount. So the equation will look like y is equal to mx plus b. And therefore, when you have like an initial amount or a base cost, the origin is not part of the graph. So you never start at the origin. So let's double check this understanding. So example 1. So we have two types of monthly service membership. Membership A is $4 per visit. Membership B, there's a flat fee of $12 plus a $2 per visit. So just by looking at the words, you will notice that membership A will probably be a direct variation, and membership B is going to be partial variation. How do you know right away? Why? Because there is a flat initial fee. Okay, so when you have like a base cost or initial fee that you have to put like a deposit, it's always going to be a partial variation. So let's take a look at the graph here. So we want to complete the table values. So we could say let, it's per visit. So let X be the number of visits. And we could say let Y be the cost or the charge. Okay, in dollar sign. So X, Y, X, Y, and I'm going to start with 0, 2, 4, 6, 8, and 10. Okay, So what you want to do is you are going to plug in. But first we have to come up with an equation. So for the equation for this one, for membership A, it's $4 per visit. So it's going to be y is equal to 4x, right? It's following this format. Y is equal to 4x. And for partial variation, there is an initial cost, which is B. So for membership B, it's going to be y is equal to $2 per visit plus a flat fee of $12. Okay, so what I will be doing now is I'm going to plug in a point, 0 into my equation. So it's 4 times 0 is 0. And then 4 times 2 is 8. And you'll be doing that same thing. So and those are the points. And then now for membership B, I'm going to plug in 0 into my equation. So 2 times 0 plus 12 is 12. 2 times 2 plus 12 is 16, and so forth. So you'll be doing 2 times 4 plus 12 is 20. Okay. Oops. And that's it. Okay. Now, so let's identify this as a discrete or continuous. Now, just by looking at it, we know that it's going to be a discrete. The reason why it's discrete is because for X value, which is number of visits, can you have 0.5 visits? Or can you break down number of visits into like a decimal point? You can't. So therefore, it has to be a discrete because you cannot break down number of visits into smaller amount. Okay, so that means when we are graphing this, we will have to use a dashed line. So let's graph this. So don't forget the title here. So I'm going to do the cost versus number of visits. So y-axis is going to be cost in dollars and number of visits. For visits, I need a number up to 10. So for every 2 boxes, I'm going to make it 2. So 2, 4, 6, 8, and 10. So unfortunately for this one, I decided to use a half of the space, but definitely you could go bigger, or you could do, let's say for example, if I don't like it small, then you could do, so 1, 2, so every 4 spaces will be 4, 6, 8, and 10, if you like that, okay, depending on the visits. Now for the cost, my cost will be going up to 40, so I could do every 2 spaces as, let's say, 5. So that means every 4 spaces will be 10. So 4 spaces, 20, 30, and 40 here. And this will be 50. Now let's plot the points. I'm going to use a different color for membership A and B. So for membership A, I will be using this color. So when it's 0, 0, 0, 2 is 8, 4 is 16, 6 is 24. So don't forget the spacing. 8 is 32. This is 30, so it'll be. And 10 is 40. Okay, so I'm pretty sure if you were to use a ruler, it will be a straight line. So I'm going to write it down. Y is equal to 4x, so which is membership A. For membership B, I will be using a pink color. So I'm starting from 12 here, not at 0, 0, and then when it's at 2, it's 16. 4 is at 20, and 6 is at 24, and then 8 is at 28, and 10 is at 32. Okay, so it looks like we are meeting at a same point here. So please use a ruler. So y is equal to 2x plus 12, and this is membership B. So write an equation relating to the cost, C for dollar, and number of membership. Well, we already did that. So for the membership A, I could say that C is equal to $4 per visit, and for membership B is $2 per visit plus an initial fee. Now use the equation to determine the number of visits for which monthly costs are the same. So what that means is that we are going to assume that the cost for both membership is the same. So what I'm doing is C is equal to C. So this is membership A, 4N, is equal to the membership B, which is 2N plus 12. Therefore, I'm going to collect the like terms by bringing 2N to the left side. So 4N minus 2N equals 12. 2N equals 12. N is equal to 6. So what does that mean? It means that N, which is the number of visits, so at 6 visits, both will cost the same. Okay, so you will notice that when you look at the graph over here at 6 visits, what do you notice? They both are going to cost $24. They intersect. And we will be learning about this later, but this is called a point of intersection. Point of intersect. That's where the two linear relations meet at the same point. So identify each relation as direct or partial. Well, we know that for membership A is going to be direct because it follows y is equal to mx formula. But the most important, the explanation that it's direct because it starts at 0, 0. Do you notice that? The graph starts at the origin. So it starts at the origin, 0, 0. On the other hand, for membership B, it's partial. Why is it partial? Well, not only it follows this equation formula, but the main argument is that it does not start at 0, 0. It starts somewhere else on the y-axis when it's 0. So you could say does not start at the origin. That's why it's going to be a partial variation. So another summary is that for linear relation, the equation is always the first degree, meaning the exponent is 1. The graph is a straight line. And for the table of values, the first differences are constant. So what do I mean by first difference? If you take a look at the table of value, the first difference is found by doing the subtraction for the y value. So if I were to subtract 8 minus 0, it's 8. Next, 16 minus 8 is 8. Same thing again. 24 minus 16 is 8. So you should do all of them just to make sure that the first difference is always constant. Same thing for membership B. The first difference is always based on the y value, assuming that the x is always increasing by the same amount. So 16 minus 12 is 4. 20 minus 6 is 4. 24 minus 2 is 4. And they're all the same. So when the first difference is same in the table of values, we know that it's going to be linear relations. For nonlinear relation, the equation is not the first degree. So your exponent will be like 2, 3, and so forth. The graph is not a straight line. And for the table of values, the first difference is going to be not consistent. Okay. Now, another thing that I do want to note is the first differences is represented using triangle y. This triangle y, we call it delta y. What that means, it represents the differences between the consecutive y values. So you could write it over here at the top, first difference, or you could do change in y. Why? Because I'm finding the difference in the change in y value for the second minus the first value, which is 8.